Hello everybody, welcome back to my channel. Today we're going to do a coding walkthrough and we're going to make a program that will give us as many primes as we want. So we'll give it a max number, let's say 10, and it'll give us everything down, 7, 5, 3, everything down to 0. And so let's just begin. Do our Visual Studio Code and let's start with our function. So we're going to make the prime function, we're going to give it a max, and let's start making our function, I guess. Let's figure out how to do this. So right about here, I have a function that will make two new lists, total and prime numbers. It will add all of the numbers from 2, which is our first prime number, up to the max number that we set. So let's say I want the prime numbers from 2 to, let's say, 12. So this function will take 12, and because a range function stops at this value that you specify, you have to add 1. So it includes 12 into there to see if that is a prime number. So this function just adds all of the numbers from 2 to 12 into these two functions, or into these two lists. Alrighty, so next we're going to make two for loops. We're going to make for A in range, and then we're going to do the length of the total list, and then we're going to do another one for B in range of the length of the prime numbers list, prime numbers, and we're going to iterate through all of the values in total. So I'm thinking what we do is we take all of the numbers in total, we divide each number in total by the next iterative amount in total. So let's say iterate A is the first index and iterate B is the second index. So we divide A by B, and if they are divisible and the remainder is 0, which we can do here, so if we do, if the numbers are divisible, which is mod, by each other, and they equal 0, which means if total index A divided by total index B gives out a remainder of 0, so let's say 12 divided by 2, that would give 6.0, right? No remainder. But if you do 12 by 5, you're going to get a different value. You're going to get 2 point, something, so you're going to get an extra fraction. So if we get to that point, then we will take the number in prime numbers and we will remove the total A, because that is the one that was being tested in this case. We also need to test for a couple more things. First, if total A is not equal to total total B, then we will move on, because it just wastes time to go through 1 divided by 1. I mean, that's obviously not going to happen. Or that's obviously not a prime number. It's not how you test it, duh. And the way I set this up, I noticed that we have to do one more conditional, which is and the total A, which is the one we're testing, is in the prime numbers, because it'll throw up an error if you try and remove a value that's not in a list already. Then we break after it's done. So it breaks this for function, so we go on to the next number. Let's test that out right now. Let's do prime to 12, and we're going to print the prime numbers, and we will see how it goes. And we also need to make it a global variable, because, why not? So let's see it run, and it's going to give us the prime numbers from 2 to 12, which is 2, 3, 5, 7, 11. So let's test it on bigger values. Go to 100. Let's see what happens here. We get all the prime numbers from 2 to 100. Look at that. That's amazing. So that's all and great. That's well and great, and you get the values down here and stuff. I want to see if I can add it into a text file. So let's make ourselves a file. Let's call it primes.txt. So this first part is the name of the file. This next part is the type of file. So txt is a text file. py is a Python file, JS is JavaScript file, HTML is HTML file. It's kind of self-explanatory. So we're going to make file1 equal open, and then we need two conditionals. We need the name of the file and then what we want to do with it. In this case, we want to write in it, so we want a W. Whoops. And then with that open, we're going to do a for loop for iterate in range. And we want to iterate through all of these prime numbers and add each one of them into the primes text file. So the way we do that is you take the length of the prime numbers list, and we make a new line. Every time we go through the for loop, we're gonna make a new line. We're gonna do line equals string value, or turn it into a string, and we're gonna take prime numbers index x, or index iterate. Whoops. And I'm going to do two more things. We're going to do file1.write, and we're going to write the line into the file. Pretty self-explanatory. And then we're going to do one more thing, which is write this little nifty boy /n/n, and that clicks enter in the text file, so you don't get a bunch of numbers side by side with each other. Some people can do this. Maybe you can do a ... So you can go, see the primes in that way. I like this, and I'll show you the other variations. And then after that, we need to do file1.close. So yeah, let's test that out here. And look at that. Worked absolutely like a charm. Whoops. Look at that. So another cool thing is that you can see how many primes are in your file by just looking at the line number. And so yeah, let's try another variation. Let's just add a triple dot, and I think they're called ellipses, not sure. And let's see what happens then. Let's see kind of what it looks like. Yeah, so you either want a super long vertical text file or a super horizontal text file. So I'm thinking the vertical one, then you can see how many primes you have just by looking at it. So that's pretty neat and stuff. But I want to do one more thing just to make our file all well and complete. I want to see how long it takes to go through this 4 for loops that we're writing in here, which is not optimized at all, but I'm not a very optimized person. So let's make a new function. Let's call it go for, go. And the way time it works is you have to do time equals timeIt dot timeIt. You name the function, and then you name the amount of times you want the function to run. So we just want it to run once. So now, I don't know why that's there, but yeah, now we're gonna run this, and then we want to print time. So let's clear this, see what happens. That took 0.003 seconds. That's great, and it did it. So as you get higher and higher, it gets exponentially larger because it's checking a larger and larger amount of total numbers. So even just by going one more zero, we tried 100 before, now we're trying 1,000. You can see it jumped up by an entire decimal, or entire zero. We add another zero. Now it's waiting. It's going to take a couple seconds. 10,000 numbers takes 2.2 seconds. So you can create a function to probably find out how long it'll take, but I like testing them. So this is a lot. So yeah, it's pretty neato. So now I want to see how long it takes to do 100,000, and I'm guessing I don't know, a minute and a half, maybe 2 minutes. Of course, it depends on your computer. I'm just working on a laptop, but if you got a beefy computer, it'd probably take milliseconds. But here we go. So we saw it took a little over 2 minutes, 2 minutes 20 seconds. If you can hear my fan from the computer, it's kind of chugging. So it did generate primes from 0 or from 2 to 100,000. So that has a lot of iterates. but it generated 9,592. So that's a lot of prime numbers. I can tell you, if you leave it on, if you make this number 1 million, which is one more zero, you can break your computer. Mine went for 3.5 hours, and it did all primes from 2 to 1 million. I think it was 78,000 primes, but it was a lot. But make sure to try and optimize this function. As you can see, it's got some weird bugs in it and stuff. But this is just my first prime test. So we'll see if we can optimize this in the future. So for this specific function, I kind of just use my own knowledge of Python and math and stuff and how prime numbers work. But in the future, for these episodes, I'm going to be going to Google Chrome and trying to figure out the problems with you guys to see if we can figure out some cool concepts in Python and stuff. So yeah, make sure to stick around for more videos, and have a great day.